Hi. So the purpose of this video is to show you how to get started writing LaTeX code. And that is how this is pronounced. It's not latex, it's LaTeX. The X here, I think, is a Greek letter chi, so it's a k sound. Okay, like Christmas is often spelled Xmas, same kind of thing. So come to this website, overleaf.com, and make an account, register an account. So use whatever email you want, I don't care. But I have an account, I use it all the time. And so I'm going to log in. And alright, so when you log in, you'll see a screen. It won't look quite like this, because this is my, all my documents I've made over the last, many years, 4 years or so since I've been using this site. But you'll have something that sort of looks like this. So to get started, go to New Project, click Blank Document, and then just give it some name. Okay. Now, once you're in here, it'll bring you to this page, and it'll give you a bunch of stuff in here. And the name of your document will be at the top. Your name will be up here, maybe. Maybe if you use a pseudonym, it'll be there. The date, and then the section. And then you can start typing. Now, notice when you start typing, nothing's appearing on the right. You have to compile the document in order for that to happen. So what this is mathematical typesetting. And that means this is how we write math books and math papers and stuff like this. It's very common in the scientific fields, engineering areas, chemistry, physics. All these places, they all use this as well. It's the industry standard as far as beautiful documents with math in them is concerned. Okay, we do not use things like Microsoft Office and stuff like that. All that has too many bells and whistles and tries to help you too much, and it lacks a lot of the capabilities that this software has. So part of your, if you're using this for a class, probably I'm having you watch this video as part of your honors class in calculus or something, and so I'll send an email to you sort of what to work on at this point. But right now I just want to show you some stuff. Okay, so some common things. Now, what we do often in LaTeX is we load packages. So use package is a common command. There's a few packages that I basically load every single time that I use LaTeX, AMS Math, and Math RSFS. I just copy and paste these from other documents most of the time when I'm doing, because there's a couple things I use a lot that are in there, and I'm going to show you stuff that's in there. So how do you get started? Well, math text occurs within dollar signs, okay? And if I compile that, and you can hold Control and hit Enter to compile, you'll see that it looks kind of italics or something, and that's because it's rendering it in so-called math mode. Okay, now a percent symbol makes a comment, so you won't see that. A comment is something you use in code to sort of explain to you as the code reader or writer what's going on. So this is math mode. If you do $2 signs, this is displayed math mode. Okay, and that you see it's sort of centered. It's kind of like I want to feature this formula. Regular math mode can be embedded into normal text, while displayed math mode always offsets itself. Okay, so you can see when I did the single dollar sign, it sort of just let me kind of continue typing, whereas when I used the double dollar sign, it sort of made it in the center, like telling a reader, like, focus on this. This is important. Okay, so how do you do algebra or something in here? Well, you don't really do algebra. You write algebra down in a pretty way. So, I could write 2x plus 1 equals 3. Okay, and if I don't do that in math mode, I'll get this ugly looking equation. And yes, that is an ugly looking equation. If I made it more beautiful and put it in math mode, you do kind of see the difference, okay? There's subtle differences. The 2 is a slightly different shape. The x is no longer like a text x. It's more like a variable x, and that's sort of happening automatically. That's because this is all italics, right? The equal sign is sort of offset a little bit, and so on. So in that sense, you know, I think this right one looks a little better. It's a little easier to read. It's easier on the eyes. And it just looks good. Now I write in LaTeX all day, every day, and so I could, if I saw this in an article I was reading or something, I would know, oh no, this is horrible. Probably the differences are subtle to you at this point. Now, where you really get power is if you want to do a fraction. So like if I want to do a over b, you know, I can write that in text like that. I can maybe look up a fancy symbol or something. But LaTeX gives us the power to do it in a nice way. So commands in LaTeX that aren't just symbols, you use a backslash. So the negative slope slash is a backslash. And frac. Now, if you look at this list, they kind of are showing you a few options you have, okay? But the first one is what we're going to look at first. And you see it has brace, open brace, close brace, open brace, close brace. If you click that, those will appear. You don't have to click that, but you can. Now, those are places where you can put stuff. For fraction, obviously it's the top and the bottom that you're wanting to put in there. And you can see it very nicely typesets you know, this stuff. Now, one fraction I really like is dfrac, which makes it sort of bigger, and it just makes it easier to read, I think. I prefer dfrac. Dfrac, if you look at this list again, you can see it says AMS math command, and we only have access to that because we have imported that package, essentially. So that's why I always import it, because I'm always writing fractions. So if I did like 2x plus 1 over 3, okay, you see, you know, this is very nice looking. Okay. Now, if you're in calculus or Calc 1 or Calc 3, you know, maybe you want to talk about a function. I know I was teaching functions this semester, so you know, you want this kind of notation, f from 0, 1 to r or something. Now, it won't really like that greater than symbol. It interprets it very strangely. But if you're in math mode, I think it interprets it just okay. So without math mode, the greater than symbol was weird. But also notice if I do 1 enter and I put stuff, it won't go to the new line. It'll continue. But if I do 2 of them, it will. And it actually tabs it over, you see. Up here it wasn't tabbed over because, well, I didn't do anything. Even if I did this, it wouldn't have done anything because you would need 2, and then when it does, it'll tab it over. You can always untab something with no indent. Okay, that's a nice command, and it'll untab stuff. I use that a lot too. Okay, some other math things, like if you're writing a function using this sort of notation, the way you can do it is F, and you could do a colon, and I'm going to actually change that here in a second. But the arrow won't look very good, and the R doesn't look very good as written. It looks better than it did, but the arrow looks kind of disjointed and so on. Now, it turns out that you can do \right arrow, and you'll get a nice little arrow there that kind of does what you want it to do. Now, the colon here, I was told by someone once that never do the colon there, do this one. So watch carefully when I compile what changes at the colon when I compile. See, it kind of tightened it up and brought it closer to the F. That's preferred, but I'm not going to be picky about that. And finally, the R. Now, usually in math, we write like the double R, right? Like the 2 vertical line with the R for the reals. Well, obviously, the regular R is just giving us a regular, like, a regular R. The way you get the nice R is mathbb command, okay? And if you do that, then we get this really nice looking notation, okay? Some other things, vectors. You could do like 1, 2, 3 for a vector. This is a Calc 3 topic. And that, where's the greater than? I must have compiled before it got the symbol. And that looks okay. I don't particularly like it. What's better is left angle and right angle, langle and wrangle, and you'll get, you know, I think they look better. They're a little more compact. It's a little less sharp. You know, visually just more pleasing. So, you know, little things like that you'll come across as you're working. Now, what happens if, and I'm just kind of winging some stuff right now for you to try. What happens if you have a vector with a defrac in it, okay? Something like this. Well, what's going to happen is that it's going to be too short, right? And that kind of looks bad. I mean, we're being really aesthetically judgmental right here, okay? But it looks kind of bad. It'd be nice if that langle was bigger. Well, you can use display style and make that happen. Or no, sorry. You can use left and right on most symbols, and they'll kind of grow to fit what's between them. And so that looks beautiful. It scales it up so that it fits. So that's a nice little feature. So let me look at the first couple homeworks here. How do I do the line above for vectors and stuff? If you have like a variable, you do \vec x, and that'll put the little arrow over it. But if you try it with AB, it won't look very good. I think it's over right arrow or something will look good. Yeah, there you go. So that those symbols are probably useful for you. Everything in, say, this homework seems pretty good. Oh, how do you do square roots? SQRT, ABCD, and it'll show. What if you wanted a fourth root or something? SQRT, open bracket, like 5, X, Y, Z. Okay, that'll give you like a fifth root symbol. Okay, and those are all very nice. That's about everything here. If you want to do like a dot product, like vecx dot vec_y, well, you use c dot for that. If you want a cross product, you'd use times. And you know, I know all these because I write in this all day, every day. As you're writing, communicate with me and just let me know, you know, what kind of things you want to see. If you do int ab f of x dx, that'll be an integral. But the integral's kind of short, so this is where the display style comes in. It makes it big and beautiful. And you know, I'm actually really picky about the D here. I don't think the italic D looks very good, so I'll put text, and it'll make it like regular text D. I like the vertical unitalic D for the differential and the italic X for the variable. But do whatever you want. I'm not going to be picky about that. For other calculus, if you want a derivative, again, I'm picky about my differentials and derivatives. You write something like this, and that looks good. Yeah, I think I covered everything for this. Now, what about plotting? These plots I made for this homework assignment, I did entirely in LaTeX. I can't do it off the top of my head, but it is possible. But since I guess some of you will be drawing these as part of your honors homework, I guess I should show you how to do it. So you need to import these two packages. So you just write them in, okay, tickz and arrows.meta. And the way tickz works is it's like an entire different programming language in and of itself. So let me copy all this junk and post it here and just kind of let you see it. Now you can pause the screen and kind of copy it, but basically you have begin center, end center. That's going to center the image on the screen, and then begin tickz picture, and I'm scaling it to make it bigger. Now the stuff in here are special things for these lines, but this command essentially draws a line from 0, 0 to 0, 1. So it's going to draw like the vertical axis, okay, in this picture. this part of the axis. And drawing from 0, 0 to 0, -1 is the bottom axis. I don't know why I didn't just do 0, -1 to 0, 1, 0, 1. It would have worked, okay? I would get the same. So if I kept 0, 0 here, I won't have the bottom half of the axis. I'll only have the top half. And then if I do -1 in there, then I'll get the bottom half as well as the top half. Ah, I remember now. Apparently this way of drawing the thing will only put the arrowhead at the end. So the way I had did it before gets me arrowheads on both sides. Okay, fine. The node command will help you label things. Okay, so you put the coordinate where you want the node, and then you put inside a brace what you want. And don't forget these semicolons because they're important. If you don't do it, it's not going to work. So see, I'm compiling. It gave me red. That means there's an error. Now, it was sort of able to fix it, but you don't want to do that too much or else your code goes haywire. So always sort of be watching up here for red. If red appears, try to fix it. Okay, and the other things, okay, these circles are these little points here. You know, I can make it bigger. So inside here is like the radius. So if I do 2 points, it's going to make one of the circles really big. And so on. So there's a million different things like this to play with, and I just wanted to show you one or two to at least get you started. So if you're doing a homework and you want to sort of number them 1, 2, 3, 4, then what you want to do is you want to include the enumerate package. And then you get inside an enumerate environment, they call it. And what this does is it lets you kind of do stuff, and then every time you do an item, it'll give you a new, you know, it's like bulleted lists, okay? You can even do something like put a bracket here, do like A, not 3, A1. It did ABC. Why is it doing 1, 1? I don't know. Let's just say like 1. Kind of style the things a little bit the way you want. And that's just window dressing, okay? But this would be helpful for homework. So if you're like typesetting problem 1, maybe do an enumerate environment, do the problem here, and then do the next problem here, and so on, okay? So that is a crash course in LaTeX. I will be happy to help you through this stuff. By the way, when you're drawing, right here is where you define the function. So this is the function x, absolute value of x. So this is the variable, and then this is the function. Okay, and that's what this function is the absolute value function. So I guess that's all I have for this. You'll at least get started this way, and then from here you'll practice throughout the rest of the semester.